right, we are back for graphing linear non-proportional relationships. This is part 2. Today we're going to analyze a graph. Many real-world situations can be represented by linear relationships. You can use graphs of linear relationships to visualize the situations and even to solve problems. So we're going to take a look here at example 2. It says Ken has a weekly goal of burning 2,400 calories by taking brisk walks. The equation y equals negative 300x plus 2,400 represents the number of calories y Ken has left to burn after x number of hours of walking, which burns 300 calories per hour. So it's a negative 300 because it's burning 300 calories. And so that's our negative 300. And that's per hour. So there's our rate of change or our slope. And then he starts at 2,400 calories that he wants to lose or he wants to burn. So that is our initial start. And so that's our y-intercept. And then we need to know about how many calories are remaining. Okay. All right. So we're going to graph this equation, and that's what they did. So we know that the y-intercept is at 2,400. So at 0, 2,400. That's this point right here. And then if they're burning 300 calories per hour, we need to be able to find where we can graph our information. One of the things that we notice is that we can always write our slope as a fraction by just putting a 1 underneath it. If I were to graph coming down 300, I notice that these are going up by 300s. And so if I came down 300 and across, that would be at negative 300 in 1 hour. In 2 hours, it would be here. And at 3 hours, it would be here. And so forth, okay? And so we were able to graph our line going across there. Let's see. They want to know, well, they just want us to graph it. So we've graphed that line, okay? Using information that we already knew. After how many hours of walking will Ken have 600 calories left to burn? So we want to know at what point is it going to be 600. And so using that same line that we had before, if we come down to where this line is crossing the 600 line here, we see that it's going to take 6 hours. So that'd be at 6 hours. When will he reach his goal? Well, it ends at 0 calories remaining here at 8 hours. So at 8 hours, he will have reached his goal. So that's where they get this. So that's using the graph to understand some of this. What if Ken decides to modify his exercise plans from example 2 by slowing the speed at which he walks? The equation for the modified plan is at negative 200 calories per hour, so burning 200 calories per hour, but still starting at 2,400. So we still have to start it here. Actually, let's make this larger. There, a little easier for you to see. So we still start here, but this time our slope is at negative 200. And remember, these went down by 300, didn't they? Because from here, this is 0, this would be 300, 600, and then it would be 900 and 1200 and so forth. So these are actually going up by 300s. And I can't go down easily at 200s. So what we're going to do is we're going to look for a common number that we can use. So if I go down, if I every 2, this would be negative 400. That's not going to work. If I go for 3, if I burn 600. This is a number I can use because 2 300s makes 600. So I can use this. So this is the one that I'm going to use for graphing. So I'm going to come down 600 and go over 3. 1, 2, 3. Down 600. So 1, 2. So 300, 600. And go 1, 2, 3. 300, 600, 1, 2, 3. 300, 600, 1, 2, 3. And so this is our new line. Going through here. So how does this graph compare to the other one? Well, the other one ended, let's change our color here. So this is our original, and it said it was going to take 8 hours to burn 2,400 calories. And this one we found is taking 12 hours, excuse me, 12 hours to burn 2,400 at the brisk walk. Okay, so this red one is actually shallower. So it's a shallower graph, which means it's going to take longer to reach his goal. Will Ken have to exercise more or less to meet his goal? Okay. Suppose Ken decides instead of walking, he's going to jog, and that means he's going to be burning 600 calories per hour. How do you think this will change the graph? Well, if the red line is at burning 200 per hour, and the blue line is at burning 300 per hour, what do you think is going to happen if he's burning 600 per hour? So 600, so if the slope is negative 600, that means for every hour it's going to go down 2. So 1, 2 here, 1, 2 here, 1, 2 here. So what's happening? Okay, so yes, it's going to go quite a bit faster. So it's got a steeper slope. It's going much faster. And it takes less time for him to actually reach his goal. Okay, so that's the green line. So the green line, that's it. That's the 600. So so it changes the graph because it becomes a steeper line. It is displayed using a steeper line. We know this because it's going to take, or it will take, less time. It will take less time to meet his goal. All right, so take what you know and graph the slope and the y-intercept of each of these equations. So we've got y equals 1/2 x minus 3. What is the slope? And what is the y-intercept? So if the y-intercept's at -3, where are we going to put that first point? At 0, -3. And the slope is telling us that it's going up by 1/2. So we're going up 1, run 2. And then we're going to draw our line. Okay, do the same for 2. What is your slope? What is your y-intercept? And what is your line going to look like? Graph these on your notes. Thank you. If you have any questions, please speak with your teacher.